So far we've been talking about power functions when the leading coefficient, or the coefficient in front, has been a positive number. The question is what happens if it's a negative number, and what happens is it becomes a mirror image of the function that had the positive coefficient in front. And if we take a look at a few of these pictures here on the right, we have a line y equals positive 3x. If I put a negative in front of that, y equals negative 3x, notice I flip right around the x-axis. Or originally, the y equals 3x had left side down, right side up. When I put a negative in front, now the left side is up and the right side is down. Flipped it right around. And that's true for any power function. Positive 5x cubed, left side down, right side up, sort of that spaghetti shape. But if I put a negative in front of that, it's just going to flip my spaghetti shape right around the x-axis, and this is the dashed line that you're seeing here. The left side is up and the right side now is down. If you put that negative in front, it just flips it right around the x-axis. Even if it's an even power, we talked about even powers where both ends were up if it was a positive coefficient, 0.5 x squared, both ends up. But if it's negative 0.5 x squared, both ends are going to be going down. It still has y-axis symmetry, but that negative in front of the number there flipped it around the x-axis. So y equals 0.4 x to the 6th, both ends up because the 0.4 is positive. The 6th power means we've got an even function. It's going to be a y-axis symmetry. But if I put a negative in front of it, it flips it right around the x-axis. So for example 4, it says describe the end behavior of the following. So I'm going to write down left end, and then leave a blank spot, and then do right end. So we're going to take a look at what is the left side doing and what is the right side doing. Negative 5 x to the 8th. First focus on x to the 8th. It's an even power, so both ends are going in the same direction. And because there's a negative 5 in front, left end down, right end down. With your graphing calculator, you can confirm this by typing in to the y equals function editor here. Let me clear out my junk. Type in x negative 5 x to the 8th and then graph it. And notice it's that horseshoe shape, but both ends are now opening downward. Right. So positive 3x to the 7th. 7 is an odd number, so I know it has origin symmetry. So I'm going to, again, look at what's the left end doing versus the right end. Because it's a positive 3 in front, the left end is down and the right end is up. It's going to be going uphill, kind of like a positive slope, if you will. Left side down, right side up. All right. And again, you can confirm that with your calculator. 3x raised to the 7th power. And I think I typed something in a little funky. Or it's just being really slow. I think I typed something in a little funky. Let's see if it'll let me get out of this. All right, let's go back into y equals. Yep, I typed in 78. So I knew something was off there because both ends were going up in the same direction. 78's a positive even number. So something was a little missed there. Let's take that 8 out. And now try again. This is why you do your algebra first, then you confirm it with your calculator. don't always rely on the calculator there. All right, sometimes you type stuff in wrong. Left end down, right end up. All right, the negative in front of an odd power. So again, what's your left end doing and what's your right end doing? Now on WebAssign, sometimes instead of saying down and up, they'll say rise and falls. So in this case, your left end rises, or your left end is up, and your right end falls. Right end down. If you're writing it up in homework, it doesn't matter which words you use, but on WebAssign, they may use those words in a multiple choice situation. All right, and it's modeled after this function right here. Negative in front, odd power, and you can kind of see with those dashed lines, what's going on with the ends. Left end up, right end down. 8x to the fourth. So left end rises or left end up. Right end, and again, it's even, so it's got y-axis symmetry. So whatever you put here, you're going to put here as well. Right end up. Check it out on the calculator. Make sure that's the case. Negative 15x to the 1 power. So that's an odd power. The ends are going to be split. It's a negative slope, so it's going downhill. So when I do my left end versus right end, the left end is going to be up and the right end is going down. Okay. Stretching and compressing the graphs of power functions. The graph of a power function y equals kx to the p, where k does not equal 0, is the graph of y equals x to the p if vertically stretched by a factor of k, if k is bigger than 1. So if your k value in front here is a big old positive number, it's going to be vertically stretched. It's going to be coming in closer to the y-axis. If the k value is a number between 0 and 1, it's like your favorite fraction, like 1/2, or a decimal like 0.33, it's vertically compressed by that number, whatever that number is, 1/2 or 0.33. Vertically stretched or compressed by a factor of absolute value of k and reflected across the x-axis if k is less than 1. We'll give you some examples of that in just a moment. But here's where you can see, if I have a decimal, like 0.25, 0.5, that's less than 1, like 1x cubed here, it's going to be pushed down closer to the x-axis. It's compressed. But if these numbers get bigger than 1, like 5x cubed or 10x cubed, it's getting stretched up by that factor. So we would say this is vertically stretched by a factor of 10. Factor just means multiplication there. All right, but this one, the 0.25, since that's a number less than 1, bigger than 0, this is vertically compressed by a factor of 0.25. Okay. The same with the even degrees. Notice, here's y equals 1x to the fourth. All right, that's my basic parent function, if you will. It's the standard. If I start putting bigger numbers in front, I'm stretching my graph up, and it's getting skinnier. 0.5 in front or 0.25 in front of x to the fourth, and it flattens it out or it compresses it. And again, same wording here, vertically stretched by a factor of 10 when I write 10x to the fourth, or vertically compressed by a factor of 0.25 when I multiply the x to the fourth by 0.25.